Hello everyone, I'm Aniqua Baset. I'm a second year PhD student at University of Utah. So let me start. So not a day goes by when we don't hear about any news of hacking and data breaches. In a lot of cases, were a result of some insecure common coding mistakes, especially a lot of them are result of injection attacks resulted from missing or incorrect input validation. So what we can do about to solve these problems? So previous research showed that it is become more costly and costly if we want to try to fix this at the later stages of development. So it's better to incorporate the fixing at the coding phase. So in this talk, I am focusing on how we can equip the developers with tools more friendly to use and to encourage them to have secure coding practices. We know there are a lot of static and dynamic analysis tools available. So what's the problem with those to use those at the coding phase? So previous studies showed that some developers have concern that if they need to use a separate tool to do the analysis, it disrupts their workflow. They need to move back and forth between their IDE and the tools they are using to check security flaws. And also there were some complaints about correlating previously learned security issues with code in hand is hard. And also the outputs are hard to understand. So we are thinking it would be better if we can incorporate the security analysis with the IDE, then there is no context switch. Also, when we get the security flaw information just in the code which is causing the problem, then it would be better to understand and fixing those. So what did I mean by incorporating security analysis in IDE? So in recent days, there are some plugins available that you can include in your IDE. Then you can start the static analysis within the IDE, like a regular button press, like how we start the compiling. And then it shows the analysis result, like the common compiler errors. So there is a list of flaws at the information pane at the bottom, and also the line with the problem has some problem markers with it. So this type of feedback is quite common to us. We are more familiar to us, so it will be more helpful to have this kind of functionality. So in this work, we did a review of such available IDE plugins that has security functionality. So we tried to find out their availability, like they are free or commercial, if we have open source tool or not, what IDE language they support, what type of feedback they provide, and if they have any additional features, which vulnerability checks they perform, and are they popular or not, stuff like that. So how we did it, so how we built the list of the plugins that we want to study is like we went through the listings of plugins from different IDEs. We also look at the static analysis tools to check if they have any plugin version of it available. We also obviously check the academic papers, and also we go through the forum discussions to check if people are talking about some plugins. So for this work, we focus on input validation related vulnerabilities, and also we wanted to do this from a perspective of a regular developer, so to understand what the problem they face to gather information about these plugins. So this is what we got. We got total 17 plugins. 4 of them were from academic studies. Let's look at some more information about them. So here are the availability information of all these plugins. So how easy or hard to access security plugins? Not hard, we can say. There are 9 free plugins available, and 5 of them are open source. So if developers want to dive more into how these plugins work, they can do it. Next, we looked at their dates introduced and last update to check is there continued support for them. We can say mostly yes, not much for the academic ones. But another thing to note that it doesn't necessarily mean that no recent update does not necessarily mean that there are missing vulnerabilities, because some of the problems are still valid. They are not totally obsolete. So this SQL injection or cross-site scripting, the definitions is not changing that much. Okay. So here are the information about the supported IDEs and languages and platforms. So a lot of them are Eclipse plugins, and we also have a lot of Visual Studio and IntelliJ. Mostly Java support, but we also have C++, .NET, Python, JavaScript, PHP. So the question we had, do these plugins support mainstream IDEs and languages platform? We can say mostly yes, but we are but we are hoping to see more tools focused on mobile platforms, but we found only 3 that just focused on Android. Excuse me. So what type of feedback they provide? So they provide the detected vulnerability description kind of varies plugin to plugin. Here is 2 examples. The first one is quite short. It is just saying that there is an unconstant string in the SQL statement, and there is a chance of a SQL injection attack. And the second one is quite long. It's saying that what did it mean by injection attack? So that means an attacker can have some malicious input and how it's going to affect it. A lot of more details, not just saying that it is SQL injection. So the next, if they provide any mitigation, not really. A couple of them suggest some code changes, but they are kind of general suggestion. Like here is an example of parameterized query, something like that. And only few support quick fixes that is specific to the code in hand. Next, we check if there are any additional features. So we found that there are 2 features that this plugin supports: select or unselect checks and suppress warning, but very few support these features. So these features are useful when the tools are generating a lot of false positives, and in that case, having a functionality like suppress warning will help the users to get rid of that. So next, what vulnerability check these tools perform. So the top ones are all the input-related vulnerability that has support in these IDE plugins. Improper input validation, command injection, OS command injection, cross-site scripting, SQL injection, LDAP injection, SML injection, unsafe reflection, and path injection. So as you can see, not all provide support for all, and you can see that there are some blank spaces. So for these 2, they actually use multiple analysis tool and then provide a combined result, but a combined vulnerability check list is not available, so we could not verify which checks they perform. And for these 2, what checks they perform, the full list is not publicly available. So among these all checks, you can see that SQL injection is kind of the most common among all them, and the next is cross-site scripting. Not as much as SQLi, but still quite good support. So I described like what tool we found and what information we found about those tools. Now, what made us sad is this whole process. So the first problem we noticed that, okay, there is no separate security category in IDE plugin listing. So if a developer want to use a tool, want to find the security tools, they need to go through a lot of code analysis tool to figure it out which one is actually provides security functionality. So the exception is Visual Studio. They have a security category, but most of the plugins at that category is primarily for code obfuscation and group code access. So it's not like that Visual Studio has a lot of categories compared to others. Visual Studio has only 22 categories compared to Eclipse has 51, IntelliJ has 50, and NetBeans has 24, but none of them were for specific to security tools. The next problem we found is like there is lack of documentation about the supported vulnerability checks. As you remember, there were some blank spaces about some of the tools, and also the other checks, other information we gathered, some of were very comprehensive, and they had CW, they have CW and CVLEs, but others are not that good to check what vulnerability they perform. The next problem is there is no way for developer to know how good or bad their detection performance is. None of them provide any benchmark result. We found only one tool that provided benchmark result against OWSP benchmark, but they just a couple of weeks ago discontinued the plugin support, so we excluded that from our study. So this is what we did and what we found while doing this. And also we feel like how it made us as it will make the developer also frustrated, and it will contribute to lower adoption. So what next? So what we are doing? So we are mainly interested in the usability testing of these tools, how easy or hard is to do the initial setup, and also what is the effect of different type of feedback styles. Do we need feedback for different level, different experience level of users? Do we need different type of feedbacks or not? The next is there is a need for, we want to do a comparative vulnerability detection performance evaluation, maybe using the existing ones, or maybe having a public benchmark available that can be useful to do a comparative evaluation. And the third thing we are interested into looking at the applicability of these tools in using at the programming language education. So maybe this tool will be more helpful when we are first teaching the students about programming, so that they will be more aware of the problems that might have, and then at the later when they really go to industry, they already know about secret coding practices. So so there might be need for redesigning the course or assignments to incorporate the use of this IDE plugins tool more better. So this is all. So I hope I did a very bad job, and you do have some question about the content.